In this video, we're going to explore two properties, the commutative property and the associative property. So let's start with the commutative property. We're going to label to see if each of these statements are true or false. So the first one says 5 plus 4 equals 4 plus 5. They're both addition, each side of the equation. They're the same numbers, but the order is different. 5 plus 4 is 9. 4 plus 5 is also 9. So this is a true statement. The next one, 10 minus 3 equals 3 minus 10. Again, they're the same numbers, same operation. Both of these are subtraction, but the order is different. This one's 10 minus 3. This one's 3 minus 10. 10 minus 3 is 7. 3 minus 10 is negative 7. Think about if you have 3 of something and you try to take 10 away, you end up in the negatives because you didn't have that many. This is not a true statement, so this would be false. The next one is 7 times 6 equals 6 times 7. Same operation, multiplication. The order is just different with the same numbers. So 7 times 6 is 42. And 6 times 7 is 42. So this one was also true. And the last statement is division, denoted by a fraction bar. So 2 divided by 4. There's two different ways you could write that. You could simplify it as 1/2, which is what I'm going to do. But you could also do 0.5. So those mean the same thing. The one on the right-hand side is 4 divided by 2. 4 divided by 2 is 2. So again, this was the same operation, division, same numbers, 2 and 4, but the order was different. 1/2 is not equal to 2, so this statement was also false. So what we just kind of discovered here is which properties or which operation the commutative property holds for. The commutative property says that the order in which you write the numbers, does not matter for both addition and multiplication. So there is no commutative property of subtraction because that's not true. So order doesn't matter if you're adding, and order doesn't matter if you're multiplying. It does matter if you are subtracting or dividing. So we have two different commutative properties. We have the commutative property of addition. And one way to write that would be like A plus B, just using some variables here, equals B plus A. No matter what those variables are, this would be true because the order doesn't matter when you're adding. The commutative property of multiplication, very similar, except obviously this time we're going to be saying A times B is the same as B times A. And this is true too if you take more numbers. I just want to make a quick note here. Like A plus B plus C is the same as A plus C plus B. This would also be considered the commutative property because all I've done is change the order of one of those or two of those. So now let's look at the associative property. So the associative property can sometimes get confused with the commutative property, but they are different. And notice how. So if you look at these examples, it's not the order that's changed. Actually, the order stays the same. What's changed is the grouping or which pair are being done first. So just keep that in mind. We'll talk later about the order of operations, but we do need to understand that we have to do the grouping or the parentheses first in order to complete this. So let's look at the first one. 3 plus 5 gives me 8, and then plus 4. And on this side, we would do this parentheses first. So 5 plus 4 gives me 9. So now I can finish this left side. 8 plus 4 gives me 12. And then 3 plus 9 gives me 12. So this is true. Now let's look at the next one. Again, the order is the same. 2, 10, 3, 2, 10, 3. They're all the same operation. And this one is subtraction. But they're grouped differently. So let's start off with this group. 2 minus 10 is negative 8. And we got minus 3 equals, I'm going to just bring down that 2, minus, and then 10 minus 3 is 7. So on the left side, it's going to be negative 8 minus 3, which is negative 11. equals 2 minus 7, which is negative 5. Well, that is not true, and so this would be a false statement. The next one is multiplication. I have used a couple of different ways that you can denote multiplication. Parentheses denote multiplication if it's sitting right beside it, but these are asterisks that also denote multiplication. So I'm going to do this group first. So I'm going to just drop the 2 down, times 4 times 3 is 12. And on this side, this group is done first. 2 times 4 is 8 times 3. On the left-hand side, 2 times 12 is 24, and then 8 times 3 is also 24. So this was correct. This is true. So true statement. And the last one is division. And again, the order is the same. The groupings have changed, which means that I have to do the order a little different. So for this one, I'm going to do this grouping first. So it's going to be 24 divided by 4 divided by 2 is 2. I guess I don't have to do parentheses there. Equals, and then 24 divided by 4 is 6, and then divided by 2. And on the left side, we have 24 divided by 2, which gives us 12. And then 6 divided by 2, which gives us 3. So that is also not equivalent, so this is a false statement. So with the associative property, we're not talking about order necessarily, we're talking about grouping. So what we know is that grouping does not matter for both addition and multiplication. So we can group any of them if that's the only operation that's occurring, and it still be a true statement. I can group whatever 2 numbers and it would still be a true statement. So we have 2 associative properties. We have the associative property of addition, and that would look like this. If I had A plus B plus C and A plus B plus C, if I group, let's say these 2, that's going to be the same as if I group the last 2. So this statement would still be actually equal. That's true. The associative property of multiplication is similar. So if I were to do A times B times C equals A times B times C, but I grouped this first 2, that's going to be equivalent to if I group the last 2.